Next question. If the Carnot cycle is run in the reverse order, we have an ideal refrigerator. A quantity of heat Q2 is taken at the lower temperature T2 and a quantity of heat Q1 is given out at the higher temperature T1. Find the work input required for the process. That is the question. We know that work done when Carnot, this is used as a heat engine, work output is W equals Q1 minus Q2, where Q1 is heat absorbed from the high temperature, Q2 is heat rejected to the low temperature. When it is run in the reverse order, it absorbs heat from the lower temperature and rejects it to the higher temperature. So there we have to do work on the system, on the engine. So work given to the engine, in order to work it as a refrigerator, it must be the same. Work W equals Q1 minus Q2. But we have the Carnot equation, Q1 by T1 equals Q2 by T2, from which Q1 equals T1 by T2 into Q2. Therefore, W equals, in the place of Q1, you write it as T1 by T2 into Q2 minus Q2, or Q2 is common, T1 minus T2 by T2 into Q2. Q2 is given in the question. So this is the answer. This is the answer. So work input, work required for the process to run the engine as a refrigerator is W equals T1 by T1 minus T2 by T2 into Q2. That is the answer. Another question. 28 joule of heat is to be extracted from a reservoir at 7 degrees Celsius to 1 at 27 degrees Celsius by means of a refrigerator. Heat is transferred from low temperature to high temperature here. Using Carnot cycle, find the work required. We can use the same formula as in the above case. We have shown in the previous problem that W equals Q2 into T1 minus T2 by T2. Q2 is given to be 28 joule. T1 is high temperature is 27 degrees Celsius minus low temperature is given to be 7 degrees Celsius. So you need not convert this into Kelvin, because whenever we take difference in temperature, you can use directly in Celsius scale or in Kelvin scale. Difference is the same in both scales. But when the temperature comes alone as a single term, you must use the Kelvin scale. So this divided by T2. T2 is 273 plus 7 degree Celsius. That is to be converted to Kelvin, because this is not difference. This is the absolute temperature. So it must be converted to Kelvin. So the final answer is 28 into, this is 20 divided by 280. Our answer is 2 joule. Next one. The motor in a refrigerator has a power output of 200 watts. If the freezing cell freezing chamber, is at 270 Kelvin and the outside is at 300 Kelvin, assuming ideal efficiency, find the maximum quantity of heat that can be extracted from the freezing cell in 10 minutes. We have to find Q2 here. Be careful that you must see my earlier postings, otherwise you won't understand it fully. I have discussed Carnot engine, Carnot cycle, etc. in somewhat detail. Extra points I will discuss immediately. Now, this is the. Now, here also you can use the same formula as in the above two problems. W, work input, W equals Q2 into T1 minus T2 by T2. So that Q2, we have to find Q2. So Q2 equals W into T2 divided by T1 minus T2. W, work, here power is given, power input is given. If power is given, work is power into time. Because power is work by time, so work is power into, so P into T in the place of W into T2 by T1 minus T2. Power is given to be 200 watts and time is 10 minutes. It must be converted into seconds to 10 into 60 into T2 is 270 Kelvin. That is given in Kelvin itself. Divided by T1 minus T2 is 30. Okay, because T1 is 300 Kelvin and T2 is 270. So that 300 minus 270. 270. 300 minus 270, that is 30. So the final answer is 108 zeros. Or this is 1.08 into 10 raised to 6 joule. 10 raised to 6 is million or mega. So you can write it as 1.08 megajoule or million joule. That is the answer. Another problem. A Carnot engine having an efficiency of 1 by 10 as heat engine is used as a refrigerator. If the work done on the system is 10 joule, what is the quantity of heat absorbed from the reservoir at the lower temperature? That is the problem. Now we know that efficiency eta is W by Q1. So that Q1 equals W by eta. W is given to be 10 joule. By efficiency is 1 by 10. So Q1 is 100 joule. Then we know that work is Q1 minus Q2. Therefore, Q2 equals Q1 minus W, that is 100 minus 10 or 90 joule. That is heat from the lower temperature. Another question. Consider a drop of rainwater having mass 1 gram, falling from a height 1 kilometer. It hits the ground at 50 meter per second. Take G, small g, constant at 10 meter per second square. Find work done by, find work done by 1. Gravity. 2. The resistive force of air. That is the question. See this. Work done by gravity when a body falls from a height h is W gravity equals mgh, potential energy at the height h. Here m is 1 gram, that is 10 raised to minus 3 kilogram. G is given to be constant at 10 meter per second square. H is 1 kilometer, that is 10 raised to 3 meter. 10 raised to 3 meter, 1000 meter. Then work done by gravity equals mgh. 10 raised to minus 3 into 10 into 10 raised to 3. That is 10 joule. Then when the drop comes to the ground, its velocity is 50 meter per second. So it has kinetic energy when it reaches the ground. And that kinetic energy is half mv square. That is half into m is 10 raised to minus 3 kilogram into v is 50. So 50 square. Half into 10 raised to minus 3 into 50 square. You get it as 1.25 joule. The total work done by gravity, or the total initial potential energy was 10 joule. But when it comes to the ground, its kinetic energy is only 1.25 joule, that is much less than 10 joule. Where does the rest of the energy go? That is lost during overcoming the air resistance. So work done against a resistance of air must be 110 minus 1.25. This was the initial potential energy and this is the final kinetic energy. So difference must be the energy spent to overcome air resistance. So work done against air resistance is 10 minus 1.25, that is 8.75 joule. Here the question is, what is work done by the resistive force of air? Work is done against air resistance. So work done by air resistance must be negative of this. This sign is very important when you attempt or when you face entrance exams. Choices will contain both plus and minus. Minus is the correct answer. So work done by, because when the drop comes down, moving down, air resistance is upward. So displacement is opposite to the force. That must be work done by air resistance must be negative. So it is minus 8.75 joule. Thank you.